I would like to call myself as a professor rather than an entrepreneur or a consultant. After 33 years of my teaching, guiding PhDs, and I entered the field. So normally the teachers will not enter. That is a we don't can't on, that is on our society, but I want to defy that. Whatever we teach, that can be practiced. Whatever that is practiced should be taught. So with that aim only I came. So today, on that area, I want to introduce something different from normal practice. Exo-composite framing. I think the teachers have way of calling some odd names. That is the way the exo has come. It is an exterior composite framing. There is an internal framing and external framing. This is for the PSG hospital, which is a very well-known hospital having 1,400 beds already. They want to add another 300 beds. This is how the story has come in. The additional beds means additional area. The adaptation for extra space can be done first adding a space sidewards, or adding a space up, or adding something up without connecting the bottom. The present rules have changed over the time, and the present needs also have changed. With that aim, this building has come in. The PSG hospital wanted to have around 5,000 square meter extra area. Actually, they wanted to have 10,000 square meter. For the first phase, they have taken us 5,000 square foot. So they wanted to have additional space, no space sidewards available. The existing building, the foundation and structure are not capable of withstanding the additional floors. Somewhere it is 8 floors, somewhere it is 4 floors, somewhere it is 6 floors. These types of addition have to be done. So there is a way. That way is planning for expansion. Hospital building, we cannot go inside or outside strengthening of the columns or strengthening of the beams. So there is a necessity of doing away from the building, not further away, providing floors above the existing floors. There is an intra-framing structure, that is a concrete structure built by L&T in 2004. So some 20 years have passed. Now the need has come to expand it. So we have gone for the strategic planning of providing 4 floors above that. When we are providing floors above that, the hospital has not to be disturbed. Then why steel? Why? There are 3 questions we are asking. 1, why steel? Why composite flooring? Why extra flooring? So this is a beam depth has to be restricted, composite flooring. Weight should be minimum. See, when I have a concrete flooring, the weight is about 400 tons on the foundation. So when we put the steel, it is just 40 tons. So the foundation is restricted. So depth is restricted. Area is restricted. When the area is restricted, for the foundation also, and the columns are to be in line with the existing columns, we have gone for something called needle foundation, putting 2 foundation outside, connecting by a beam and going to the top. Now, we have to make the cost minimum, and the deck sheet has been avoided. The reason I go for minimum number of secondary framing systems. That is, when we go for a deck sheet, we have to put beams at 1.5 meter maximum. So many beams, number one. Number two, the bottom has to be finished. The bottom has to be finished when we have a deck sheet. Hospital, it is not possible. So we have then two-way slab possible. When we use a deck sheet, only one-way slab. When we use a just farm work, it is two-way. Hence, extremely heavy cost has been minimized. Then, when we go to a beam, so the beam has to be, the beam, the total depth available to us was about 3.6 meter. Out of that, the beam depth cannot be more than 0.9. Even though we put the beam on the places where the walls are coming, the height available was only 2.7. So there is a heavy restriction. Then came our composite construction concept. Composite constructions, the main advantage is the reduction of the depth rather than the saving of the steel. Now, we have put the secondary beam and the main beam on composite construction type with the shear connector. The whole design has been done as per the new composite code, IS 13804. Now, again, the column which is going to the foundation has also been designed as a composite column. Then the steel beam, steel I-beam, has been enclosed with the concrete, with the suitable formwork, with the reinforcements as shown there. Then usually people will avoid the composite joint. So here, the secondary beams have been done with shear connector. The main beams have been designed as a moment connector as shown in the figure. Now, the whole arrangement is possible because of the availability of the shear connector, the studded shear connector of 20 mm, as shown in the diagram. Now, when we finish it off, the whole main beam, secondary beam, and the slab are shown as in the figure. So, a closer view of the beam are shown here. This project of 5,000 square meter as a first phase is consuming around 500 tons, and the whole project is scheduled to be completed within 6 months. So all these things are possible because somebody, I think we are the people who give the diagrams. Somebody have to carry it on the field. With the advantage, at that height, you can see the height. It is a 4th floor height, we have to make it. So all these things are possible because of fabricators and the field people. I'm happy to introduce the fabricator of this project, Mr. Periyasamy. I think he is in the audience. Please come here. This is a new project for Coimbatore. I don't know elsewhere it has been done. This he taken as a role model and he has done it. So far, we have almost completed 5 floors in some areas. Some area it is being practiced. The whole project of 5,000 square meters will be completed by this May. The project started in December. Thank you very much. Okay. Thank you. Can I answer some questions if it is? Yes, please.
I have several questions, in fact. Uh, did you build these as a propped or unpropped construction?
I'm not able to hear you.
Was this built as propped or unpropped?
Soft,
Propped. Propped. Or unpropped construction, composite.
composite.
So you have built, designed this as a composite, right? Steel
Yes.
concrete composite.
Yes.
Propped or unpropped?
Propped.
Propped.
Propped. Propping of the slabs rather than the beams. I think I will call it a both. Actually, the slabs are propped, not the beams.
Okay. Did you consider using lightweight aggregate concrete? Did you consider using a lightweight aggregate concrete, which can reduce the density of concrete to about 1800 instead of the normal 2400?
Yes, it is. Yes, it is. Actually, I said shuttering and the floor by floor completion has given that advantage.
What was the density of the concrete? What was the density of the concrete?
Not, not,
What was the density of the concrete you used?
not able to hear you.
If,
Please use the mic.
No, what was the density of the concrete you used?
What was the
Density.
density of the concrete?
Normal concrete or is it lightweight?
Normal concrete, 25, it is M25 concrete only we have used.
Okay.
Sorry, we will have to limit number of questions in this session because of the time frame requirements. We can take one more question if there is any. Yeah, please.
Sir, my name is Anup Kumar Dave. I work for Metechno, which is a producer of sandwich panels. The question is, for this kind of building, what are the fire considerations you have taken into account? Was it a paint or it was something else for the steel structure?
My question is not clear to me.
I was asking a question about the fire.
Fire, okay, right, good. Actually, that is the reason why we have avoided the secondary beams totally. Secondary beams have to be treated for fire. The main beams are coming under the walls. The main beams will be protected by masonry, and the secondary beams are to be painted with inducement paint.
So this was
And totally we have avoided deck slab. Deck sheets we have avoided. That is also steel. That has to be protected. That protection we have not done. The concrete directly exposed.
This was like 2 hours fire rating? Or
Yes,
2 hours?
2 hours.
Thank you.
Thank you. Thank you very much.